So this is the review sheet for domestic electricity, which is 3.4. It's the fourth unit of physics, but it's the second one I've done with my year 10. I'm going to start on the left, and the first question, state the difference between alternating current and direct current. Well, AC is constantly changing direction, alternating current, whereas DC flows in one direction. And there's a couple of graphs there. That should be a straight line there. But there's your change in direction. Describe what a fuse does. Well, if the circuit gets too much current, then it's potentially dangerous. So if a fault develops, then the thin wire inside that fuse will just melt and it'll break the circuit. It'll stop that circuit. We've got a conversion then. Convert the following to kilowatts. So if you look, there's always this at the front of your exam anyway, these prefixes or SI multipliers as they call them. You've got a kilo is there, which is times 1 times 10 to the power 3. That's all that means is that it's 3 times bigger than a normal. So if this was a kilometer, then there's 1,000 meters in. So 1,000 being, if I just write that, so 1,000. So that's your 3 zeros. I don't think I explained that very well there, but that relates to that 3 there. 3 zeros on top of that. If it was a megameter, which you can get, it's going to be 6 zeros. So there's going to be 1 meter is equal to 1, 2, 3, 4, 5, 6. So we're increasing in size there. And then obviously this one is the negative side. But I'll do a lesson on that on its own anyway. But I just want to show you that when we come to here then, when we're converting from kilowatts back down to watts, they usually get smaller, because obviously there's going to be 1,000 watts in 1 kilowatt. So if 500 equals 1 there, if 1,000 equals 1 there, then 500 is going to equal 0.5, because you're kind of going down. So you need to divide by 1,000 now. The same with that, divide by 1,000. You're kind of taking a decimal place back 3 places. 1, 2, 3. And it's going to be 1.5, and then for this one, so I'm going to be taking it back 1, 2, 3. But I'll do a lesson again on that, because it's very important, especially at higher. And then what is a consumer unit? Well, I don't think I got a diagram on here, but the consumer unit, you'll find one in every household. Contains the main switch and the fuses for all the fixed circuits, so such as the power ring circuit. For the lighting circuits, it's basically the fuse box. If something is wrong with your light, so if you've got too much current going through your lights, then your fuse is going to blow for the well, it's not going to blow. You're going to have an MCB, and we're going to get to these now, whereby the electromagnet is going to pull that pin and disconnect the circuit. But that's all a consumer unit really is a fuse box in the house. It's where all the switches and fuses are kept. Name and state what each wire does in the ring main circuit. Well, this is going to be the same as you've got a plug here as well, and they do exactly the same things really, these wires. So you got the live wire, which is a red-brown wire. This carries the current to the house or the appliance at high voltage. So this is constantly on, this red. This one's always carrying this current at high voltage. Okay. Now your blue kind of takes it back. It completes the circuit. So it completes the circuit, and it carries a current away from that, from the appliance, but it's going to carry it at low or even 0 voltage. So that's the main difference. So the live kind of takes it there at high voltage. The blue takes it back at a 0 voltage. So that's what the blue does. And then the green is your safety feature. Your green is the earth, and it carries current safely to the ground if a fault develops in a metal framed appliance. So a metal framed appliance, something like a cooker or a fridge, where if a live wire or a neutral wire gets disconnected and it starts touching the metal casing, obviously that metal casing is a good conductor of electricity, and if you touch that appliance, then you're going to get an electric shock unless it's been earthed, and that's what the earth wire does, really. It's a safety feature. So that's all you've got to remember is green is safe, is a safety feature. It'll carry that current down to the ground in metal framed appliances. And then what is the main voltage supply in the UK? Well, it's 230 volts, and I should have put really, and what is the frequency of that? And it's going to be 50 hertz. So in the UK, it is 50, oh my God, my right in shocking, 50 hertz. So remember we talked about the lights flashing 50 times a second. So hertz is and this is gonna be related with AC current. We've done this one. Well, let's go on to this 3-pin plug because we just kind of did this. Again, it's the same sort of thing. Your blue is this side. Your live is going to always be connected to this fuse. This fuse is going to have a thin wire, little thin wire in the middle, that if it's too much current, it's going to melt. And then you've got the earth at the top. This is going to be the green one. So the earth is the safety one. You've got the live wire carries current to high voltage, and the blue carries away at low voltage. So that's pretty simple, I reckon. Before we get into car, which one? And then what fuse? So I've missed this purposely because I'll come back to this now. What fuse value should you use for the following appliances? Well, fuses, you want them to be slightly higher than the current, because obviously if I use a 3 amp or a 5 amp fuse on a kettle, well, it runs at 10 amps anyway, so it's just going to melt the wire straight away. So it needs to be slightly higher, just in case, because if a fault develops there and the current goes up and it starts increasing, it's going to melt that fuse. So again, 5 amps, you can't really use a 5 amp fuse with a 5 amps because it's just going to melt. So I've got to go on 13 amps there. 2.5 I can use a 3 amps. 4.3 I can use 5 amps. 9 amps is going to be 13, and then 1.5. So everything's slightly higher than the given value here, slightly higher. And obviously there's only 3 fuses we can use. There's only a 3 amp fuse. We can only use a 5 amp fuse or a 13 amp fuse. The rest then it starts going into the miniature circuit breakers or residual circuit breakers. Which brings us nicely on to circuit breakers. What are circuit breakers? Well, I'll tell you now. Circuit breakers, they're automatically, not manually, automatically, it's an automatic thing, operated switches that protect circuits from overloading. You've got MCBs, which are miniature circuit breakers, or you've got RCCBs, which are residual current circuit breakers. So these protect the user and these protect the circuit, really. Okay? These ones are more sensitive. It says there, what's the difference between the two? RCCBs are more sensitive than MCBs. So MCBs are used for low energy requirements, like at home, and these are more sort of factory. These protect the circuit. And they use, well, we'll explain how they use, explain how circuit breakers work, use diagrams to help. Well, I haven't done a diagram, but I said when a large current flows, you've got this thing called an electromagnet. Will separate contacts and break the circuit. The best way to have a look, if you're still wondering what I'm on about there, just check out a YouTube video and say how does a circuit breaker work, and it's really not that complicated. After the fault is repaired, the contact can be pushed back in. So basically, you've got a circuit, and you've got this part of the circuit might be a magnet here, and if there's too much current, it'll just pull that pin out, so it breaks the circuit. I know that's a shocking diagram. I shouldn't have even gone there, but like I said, the video is the best thing for that. Then